Do you know what happens when Earth loses its magnetic field? At first, the question sounds less alarming than many other planetary disasters. The oceans remain, the atmosphere remains. The continents remain exactly where they are. There are no giant explosions, no sudden earthquakes, no visible crack forming across the planet. Most people imagine that a magnetic field is simply a scientific curiosity, something that affects compasses, something pilots and navigators occasionally think about. Perhaps satellites experience problems, perhaps the northern lights disappear, perhaps technology becomes slightly less reliable, but life continues, cities remain standing, the sky remains blue. The world appears largely unchanged. After all, Earth's magnetic field is invisible. Most people spend their entire lives without noticing it exists, so if it vanished, how much difference could it really make? Perhaps very little. Perhaps humanity adapts, perhaps the planet simply continues as before, but that's not even the most dangerous part. The real danger is that Earth's magnetic field is not simply a navigational tool. It is a shield, a planetary shield, one that has been protecting life continuously for billions of years. To understand why that matters, we first need to understand what the magnetic field actually does. Deep beneath your feet lies Earth's outer core, a vast ocean of molten iron and nickel. As this liquid metal moves, it generates electric currents. Those currents create a magnetic field extending far into space. The field forms an enormous protective region known as the magnetosphere. Most of the time, nobody notices it, because it is constantly working, every second, every day, without asking for attention. The sun is not a quiet object. It continuously releases streams of charged particles. This flow is known as the solar wind. Under normal conditions, Earth's magnetic field deflects much of that radiation. The particles are guided around the planet. Some become trapped, some are redirected. Some produce the auroras near the poles, but most never reach the surface in significant amounts. The shield absorbs the encounter. Life continues. Now imagine that shield suddenly disappears. The atmosphere remains. The oceans remain, the continents remain, but the invisible protection surrounding them is gone. At first, almost nothing appears different. People wake up, traffic moves, markets open, aircraft fly. Ships cross oceans, the world appears normal. Yet high above the atmosphere, conditions begin changing immediately. Solar particles that were once diverted now travel deeper toward Earth. Satellites become the first major victims. Many modern satellites already operate in a hostile radiation environment. Without magnetic protection, that environment becomes far more severe. Electronic systems begin failing, sensors become unreliable, communication satellites experience disruptions, navigation satellites experience disruptions. Weather monitoring systems experience disruptions. One by one, pieces of the infrastructure surrounding Earth begin weakening. The average person may not notice immediately, but the systems supporting civilization already have. Then comes the damage phase. Earth's magnetic field does not directly hold the atmosphere in place. Gravity performs that role. But the magnetic field helps protect the upper atmosphere from constant erosion by solar particles. Mars offers a warning. Billions of years ago, Mars possessed a stronger magnetic field. When that protection weakened, the solar wind gradually stripped away much of its atmosphere. Mars became colder, drier, less capable of supporting surface water. Earth is far larger and possesses important advantages. The atmosphere would not vanish overnight, or even within centuries, but atmospheric loss would begin accelerating, very slowly. Almost imperceptibly, yet relentlessly. The process is measured in long time scales, and long time scales are often where planetary changes become most powerful. Then comes radiation. Not the dramatic radiation often portrayed in fiction, the quieter kind, the persistent kind, the kind that accumulates. Without magnetic protection, more charged particles penetrate deeper into Earth's environment. Airline crews receive increased exposure. Passengers on polar flight routes receive increased exposure. Astronauts face greater risks. High-altitude operations become more dangerous. The closer you move toward the upper atmosphere, the more apparent the problem becomes. Then the escalation begins. Satellite networks become increasingly unreliable. Communication systems experience growing disruptions. Navigation accuracy declines. Weather forecasting weakens. power grids face greater vulnerability to solar storms. Electrical infrastructure becomes harder to protect. Insurance costs rise, maintenance requirements increase, economic pressure spreads, governments invest heavily in shielding technologies, space agencies redesign missions. Telecommunication networks adapt, yet the sun continues doing what it has always done, releasing energy, releasing particles, releasing radiation. And now fewer barriers exist between those particles and Earth. Then a powerful solar storm arrives, not necessarily an unprecedented one, simply a strong one. Events like this have happened before. The Carrington event of 1859 produced geomagnetic disturbances strong enough to disrupt telegraph systems around the world. Modern civilization is vastly more dependent on electronics than the 19th century ever was. Without a magnetic field, similar events become far more consequential. Power grids experience greater stress, transformers fail, communication systems suffer interruptions. Navigation becomes unreliable. A highly connected civilization suddenly discovers how dependent it is on invisible protection. Certain industries face extraordinary challenges: aviation, telecommunications, space operations, navigation-dependent logistics, scientific research, military systems. The consequences spread unevenly, but they spread. Years pass. Humanity develops new technologies. Additional shielding is installed. Satellites become more resilient. Power systems become more robust. Civilization attempts adaptation, because adaptation is what civilizations do. But adaptation requires resources. Adaptation requires stability. Adaptation requires time, and the magnetic field once provided protection freely, every second, across the entire planet. Then decades pass. Atmospheric erosion continues, still slow, still difficult to notice directly, yet measurable. Scientists track changes in the upper atmosphere. Space weather becomes a larger concern. The challenge is not immediate extinction. The challenge is maintaining complexity, because complexity depends upon stability, and stability depends upon protection. Then millennia pass. The consequences accumulate, not through sudden catastrophe, but through constant pressure. The same way a coastline changes beneath countless waves, the same way mountains erode beneath weather. The same way planets evolve beneath cosmic forces, Earth becomes a world increasingly shaped by direct interaction with the sun. The relationship changes, the balance changes. The conditions supporting civilization become harder to preserve, and perhaps that is the most unsettling realization of all. The most important systems protecting life are often the ones nobody can see, not because they are distant, but because they are constant. The air around you, the gravity beneath you, the magnetic field extending far above you, invisible systems working continuously, silent systems maintaining balance. Most people never think about them because they are always there, and because they are always there, they begin to feel permanent. But permanence is often an illusion. The foundations of life are not always visible. Sometimes they exist deep beneath the crust. Sometimes they exist high above the atmosphere. And sometimes the difference between a habitable world and a hostile one is an invisible shield stretching quietly through space, a shield that never asks for attention, yet protects every breath, every signal, every satellite, and every moment of ordinary life. If you enjoyed this journey into the hidden systems that keep our planet alive, please like, share, and subscribe to the channel. What question about Earth's fragile, hidden systems would you like us to answer next? Let us know in the comments. Thank you for watching. Stay curious.